Good afternoon, all. This is week 5 sensor and actuator problem solving session. I'm ARPITA Biswas, a PhD scholar at IIT Jodhpur in electrical and engineering department. So we will wait for 2-3 minutes, then we will start our session. Good afternoon, all. So let's start the session. This is week 5 sensor and actuator class. This is a problem solving session. So if you have any doubt, then you can discuss with me. I'm Arpita Biswas. This is about me. I'm Arpita Biswas, a student of a student of PhD in Electrical Engineering Department in Indian Institute of Technology, Jodhpur. And this is my educational background that I did my MTech and micro nanoelectronics from IIIT Jabalpur, and I did my BTech from Macau, West Bengal University of Technology in Electronics and Communication Engineering. And this is more details about me. So this is class schedule is every Tuesday 7 to 9 p.m. So let's start our session. So we are moving towards the question number 1. So is silicon ingot is subject to crystal trimming and diameter grind. After flat grinding, the silicon wafer has one primary flat with secondary flat at 45 degrees. The doping and orientation of silver wafer is the first option is P type 100. The second option is N type 100. And the third option is P type 111. And the fourth option is N type. So please unmute yourself and try to give the answer. What is the right answer? If the angle between primary cut and the secondary cut is 45 degree, then which type of silicon wafer is it? This is P type 100, N type 100, P type 111, or N type 111.
When it's 45 degree, then it's P type 100.
P type 100. Why it
Yes.
is P type 100? Let's tell that if it is 180-degree, then which type of silicon wafer it is?
N type 100 when it's
Okay,
180.
then yeah, if it is ninety
On
degree,
45 it's N type 111.
yes, the right answer is N type 111. Next, moving towards the question number 2. The first assertion is wet oxidation is faster than dry oxidation. And the reason is water molecule dissociate at high temperature and form hydroxyl prior to reaching the silicon surface. Hydroxide has faster diffusion mobility in silicon dioxide than the pure oxygen. So the first option is the assertion is correct and the reason is the correct explanation of it. And the second option is the assertion is correct but the reason is not correct explanation of it. And the third option is the assertion is wrong but the reason is the correct. And the last option is both assertion and reason are wrong. So please unmute yourself and try to give the answer. The assertion is the wet oxidation is faster than dry oxidation. And the reason is water molecule dissociate at high temperature and form the hydroxyl prior to reaching the silicon surface. And the hydroxide has faster diffusion mobility in silicon dioxide than pure oxygen. Please unmute yourself and try to give the answer.
Second option.
Mm,
अभी बाद में अर्पिता यू आर म्यूटेड
okay, okay. So the right option is the first option. The assertion is correct, and the reason is correct explanation of it. Because bed oxidation is faster than dry oxidation. Here is the reason that water molecule dissociate at high temperature and from the hydroxide prior to reaching the silicon surface. And hydroxide has the diffusion, faster diffusion mobility than the oxygen. That's why the in the silicon oxide then prior to oxygen. So the right option is the first option. Next, we are moving toward the question number 3. Then the nitrogen gas is the oxidation system is used as the process gas during system ideal, temperature ramping, wafer loading step, and chamber puring because nitrogen does not react with the silicon at the processing temperature. A trace of HCl gas is passed along with the process of gas nitrogen. For dry oxidation of silicon wafer, this helps as the first option is the chloride ion reacts with the mobile metallic ion such as sodium ions to form the immobile chloride compounds, thereby the undesired oxide charge occurring at the silicon dioxide interface can be neutralized. And the second option is the existence of hydrogen chloride which allow the some chloride atoms to be integrated in the oxide films and blind and bind with silicon at the silicon oxide interface, which minimize the number of the dangling bonds and improves IC device reliability. And the third option is they trends to increase the oxidation growth rate by about 10 to 15%. And the fourth option is the all of the above. So please unmute yourself and try to give the answer.
जो मन आ रहे खा रहे जो माने अढ़ेल माने कोई हिसाबे ना उसको कहीं देना ना
Shamal Misra.
बोलबो तो yeah बताओ ना अभी फिलहाल ये वर्तमान
So this is our question number 3, and please find the right option. Then the question number 3 is nitrogen gas in the oxidation system is used as a process gas during system ideal, temperature ramping, wafer loading step, and chamber puring. Because nitrogen does not react with the silicon at the processing temperature, a trace of HCl gas is passed along the process gas nitrogen for dry oxidation of the silicon wafer, and this helps as a the first option is chloride ion react with the mobile metallic ion such as sodium ion to form immobile chloride compound, thereby undesired oxide change occurring at the silicon dioxide interface can be neutralized. And the second option is the existence of hydrogen chloride which allows some chlorine atoms to be integrated into the oxide film and bind with silicon at the silicon oxide interface, which minimizes the number of dangling bonds and improve IC devices reliability reliability. And third option is they trend to increase the oxidation growth rate by about 10 to 15%. And the last option is all of the above. So please unmute yourself and try to give the answer. Shamal,
Yeah, I'm trying.
okay.
उसके बाद और टाइमिंग भी बता
Carefully
देंगे
go through the question and try to solve it.
नियम के अनुसार पूजा करते हैं दिन भर के खैले पीले और अंडा पीला खैले वही कपड़ा में ऊपर से बनल कर बना के ये बात ना बोल तो शाम के बाद तो होत रहो शाम के बाद होत रहो सब बोलत रहो तो सुनत रहे क्योंकि पता तो पढ़ल नहीं हम तो ये ठीक ना है क्योंकि बस सब मंगल की बात हो रही है लेकिन ये चला बचल तो ओकर बाद अपने खा मामा घरे रहो दूसरा दिन में खा के वो मर्दाना आदमी की जाए दो चीज ना बनेला चाहत है पहले खुश रहते अपने ये है ना ना कोई चीज तू भगवान के बनेगी तो पहले अपने खा ये बोला था ना आगे बोला हो चल जाते उनका जवान के लिए तू बनाइले पकोड़ा और जो भी बनाइले वो बोला में रखा लो पहले पानी देख के बताना बच्चों लोगों की खिला लेते अपने खाओ लेते जाती बारह बजे के पानी कोई बच्चा पंद्रह पंद्रह थोड़ी देर में तो बाबा होना जिसे पता ही ना जैसे खाए आप तो घूमने छूट घुमा भी कोई बोलना ही छूट लेकिन हम ये ना बोलियो कि शाम के बाद तो तुरंत फ्री है इसे कर लियो इसे कर लियो तो पता ही ना है कि कब के ना सुबह 4:30 बजे पाँच साढ़े पाँच बजे तक होलिका देख के पूजा करके होलिका देख के सुबह नहा
Please go
के
through the
पूजा
question
देख के
carefully and try to give the answer.
रात में रात टीका लगा के फिर
Simply here asking why nitrogen gas is used in the oxidation system. At least try, then I will explain.
सही है वो बोला होगा कि अपनी आता तो पूरा रोक दो लेकिन हम सोची कि दूसरा सोच के हम मंदिर को फूल को बोलिए तो पूरा ना बोले कि आप कैसे होते हैं हमरा वही ड्यूटी ये सब चीज पता कर लिया अब हाईवे तो कभी ना
Shamal,
कर दो Yeah, I'm trying, but I think all of above is right. But
yes, the right option is all of the above. Because for using the nitrogen gas, the chloride ion reacts with the mobile metallic ions, such as the sodium ions, to form the immobilized chloride compound, and also it increases the growth rate about 10 to 15%.
हमरा
So here
तकलीफ
the
ये
right
था कि
option is all of the above.
पहले वो पीछे का प्रेम चुका okay, तकलीफ कम
Next,
महसूस
we are moving towards the question number 4. A step
लगा
is
कुछ चीज
needed
दोबारा ना
for
घुसा
measuring
कोई
depth
उम्मीद नहीं
using
था
the surface
जो भी
profilometer.
है तुरंत
So,
दोबारा नहीं
the
गलती
first
से
option
पकड़
is true or it is false.
ऐसा
So,
है ना
what is the right answer?
कम से कम इतना तो आदमी कर सकती है कोई कि भाई हम
A
तो खा
step
रहे हैं
is
मैं
needed
मूली
for
खा के
measuring the depth using the surface profilometer.
मैं तो 2 टाइम हम खा सकते तो वैसे एक बैग कोई चीज ना ले ली तो मार एकदम चिल्ला के अनसन बक लेना आज धुआं से लेके यहाँ तक हमरे चलते बिजनेस
Please go through the question carefully and try to give the answer.
आई बोले मेन मुद्दा बोले तो वो की विचार है की विचार है मैं विचार की लोगों विचार को करके किया मैं ना तो खोल के बोले अभी सिचुएशन नहीं हो कि मैंने जैसे घर ले यही है कि हो सके वो लड़का यही सब खींचे खींचे के चलते बदमाशी कर रहे हैं कि एकदम ठीक कर रहे हैं कि दूर सारा पढ़ना ही ना ये तो हो सकता है ये भी देखो पढ़ हो सके चला इधर हुए उधर उधर तो पढ़ते उधर को है दूसरा बात है यार इधर चलाई मालूम पड़ेगा हमारा भी समय ऐसा नहीं कि हम कर कर सकते
Shamal,
हैं
Yeah,
go through the question carefully and try to give the answer.
वही मैं सब
ma'am, it's true.
लगभग
Because
Can
step
you
is needed for
can you
measuring.
explain why it is true? Why a step is required when we go for the measuring the depth of using the surface profilometer? What is the need of this step?
वही बात हम सब कुछ सोच के बैठ के कोई तीन चार दिन में सोच लिया कहाँ कुछ गलती हो जाए तो हम बोले
Like if you want to deposit some material one is substrate now, then
Yeah,
there is a one side of the substrate there is nothing is deposited and one side is deposited material is present. Okay, so when we go for the surface profilometer, then it measure the difference, the height difference where the material is deposited and where it is only the substrate is present, so it can measure the height, right? So that's why the step is required when we go for measuring the depth on using the surface profilometer, right?
yeah, ma'am.
Yeah, the right option is true. Next, we are moving towards question number five. During the thermal evaporation technique, substrate holder hold the wafer surface parallel to the direction of evaporation from surface source material. So first option is true and the other option is false. So what is the right answer? At first, go through the question carefully, then try to give the answer. During the thermal evaporation, so at first tell me, thermal evaporation is CVD or PVD technique? Do you know about CVD or PVD?
Yeah, yeah.
What is the full
Physical
form of CVD?
chemical vapor deposition and the
And how many types of chemical vapor deposition is present?
अरे राजीवा
chemical vapor deposition and physical vapor deposition. There are two.
No, there are different type of CVD and PVD technique are present now. So I'm asking
Yes.
about the CVD techniques. Like there are basically three types of CVD technique is present.
Yeah.
So I'm asking about it.
Iron settling technique.
Sorry, I'm not getting you. Speak loudly. Have you heard about APCVD, atmospheric pressure chemical vapor deposition, or
Yeah, yeah.
MOCVD? Or
Yes, ma'am.
LPCVD, right? PCVD,
Yes, ma'am.
plasma enhanced CVD. So, what is
Yes.
the basic principle of the CVD system? Like how the, material is deposited in CVD system? Do you have any idea?
There is a chamber in a CVD system where the different inert gases or different type of gases we are living on the system on the chamber, and we are settling we are depositing on the wafer.
Only gas is present, or something else is present
Chemicals,
there,
chemicals, some different type of chemicals also.
and we heat it up now. At first,
Yeah, we
we
heat it.
give some heat, and then it start to evaporate, and there is a some inert gas is also present. Then it is deposited on the material. Like this is called
Yeah.
CVD technique. And what is happening in the PVD technique?
Physical paper deposition. It's a dry technique basically, uh, where sputtering like ions. Uh,
Argon, inert argon.
yeah, I mean, different
It
type of
is
ions.
sputtered on the target material, and some amount of target is deposited on the material.
Yeah,
And we have to
this
maintain the
process.
conditions also, na?
Yes, ma'am. At a certain temperature, pressure, this type of.
So thermal
Maybe
evaporation technique is a CVD or PVD technique?
thermal evaporation is PVT technique.
PVD technique. So
Yes.
what is happening in thermal evaporation? Where we have taken the substrate and where we have taken the source material. And here asking about the angle between it. The substrate holder holds the wafer surface parallel to the direction of the evaporation for source material. So it is right or wrong?
Yeah, yes, ma'am. It's true.
How it is true? In sputtering, it is different for, but in a thermal evaporation, it is totally different now. In thermal evaporation, this type of surface holder is present, and here the wafer is present where we have to deposit the material, and here the source material is present, and here the gas is flowing. So the angle between this is, it is not parallelly, because for a sputtering system it is parallel, the source material and the evaporation and where we have to deposit now, it is parallel.
Yes.
But for the thermal evaporation technique it is perpendicular to each other, right?
Okay, ma'am.
So here the right option is
False.
false.
हमारे जाते ना मालूम है कि हमें हमसे
Next, we
लोग
are moving toward the question number 6. Select the correct combination. So, what is telling in the first option, it is showing that if input energy is electrical and the output energy is mechanical, then the material property is electrostatic. And the second option is the input energy is magnetic and the output energy is thermal, then the material property is magnetoresistance. And the third option is input energy is thermal and output energy is electrical, then the material property is pyroelectric. And the last option is if input energy is mechanical and the output energy is magnetic, then the material property is magnetostriction. So here multiple option is right. So
Yes,
at
ma'am.
first
Third
go
one
through
is
the
right.
question.
Yes, ma'am. Third one is right. I have
Okay,
confirmed.
third one is right. Okay, and here multiple option is right. So any other option is right here?
Electrical.
Go through the question carefully at first.
कल सुबह जब बोले कि हो ना तो जैसे लोग इम्पोर्ट
Because more than one or two option is right here.
तेल मसाला लगा के बोलबे करा तो कल भी बोल रहे हम घर में सुन रहे
The fourth one is also
बोले कि
right,
नहीं
ma'am.
देंगे सर आपको
Mechanical
देंगे
Okay,
to
third and fourth is right
magnetic
option. And
restriction as
any
visible.
other?
बोले कि आप तो देवे नहीं करेंगे सर आप नहीं देंगे मार गाली फाली कर रहे हैं और बाद छोटा के बात
Resistance.
कि छोटा के खाएगा छोटा खाएगा ना खाएगा
No, ma'am. I think third and fourth is right.
And what about option A and option B?
आगे से सारा कोई के नहीं
Uh, Ma'am, option is input is electrical and output is mechanical, so it can be electromechanical system.
भगवान कसम बोल रहे
Yes, but it is also called the electrostatic, na? You can recheck. It is already discussed with the lecture video that if input energy is electrical and the output energy is in mechanical form, then the material property is called the electrostatic.
लड़का तो जो
But
बात है
so the option A is also the right option. And what about the option B?
Thermal.
Input energy is magnetic and the output energy is thermal. So material property is magnetoresistance or not.
सब सामान लेके ऊपर अलमारी चाबी का लेके हम अपना रास्ता देखे यदि रविवार यदि लाइन में तो उन लोग यदि हम एक खुला बोल रहे यदि वन हो तो वो यदि एडमिशन करा देती तो
Magnetic
रास्ता
thermal.
मैक्सिमम होती हो कुछ मिल के करंट देते ही हो उसको मतलब करना तो फिर अपना
I have a doubt in second.
देखो
No, actually, second option is wrong because
Yeah.
magnetoresistance. If resistance is changed, na, in that time we can say that magnetoresistance. But here the thermal energy is changing or the output energy is thermal. So here the right option is option A, C, and D.
Okay.
Have you got the answer?
Yeah, yeah.
Okay.
Oops.
Next, we are moving towards question number 7. A material with negative thermal coefficient of expansion will expand when the temperature is increased. So, it is true or false? Go through the question carefully, then try to give the answer. A material with negative thermal coefficient of expansion will expand when temperature is increased.
No, it's false.
Yes, the right option is it is false.
Yeah, it's false.
Next, we are moving toward the question number 8. An MQ8 gas sensor senses ammonia, alcohol, hydrogen, or smoke. MQ8.
I have no idea about MQ8.
You can
Can you
guess, no?
explain? Okay, I will guess. MQ8. There is some full form of MQ8.
MQ8 gas sensor is basically used for the hydrogen
Gas
sensor.
sense. Oh, okay.
Okay,
Hydrogen.
so
What is the MQ?
actually, this code term is used for the different type of gas sensor like MQ3, MQ8. You can see the
Okay.
full form of the MQ. Okay.
Okay.
Okay. Next, the question number 9. Oxide layer used in MQ3 gas sensor is stannic oxide, aluminum oxide, stannous oxide, or silicon dioxide.
Silicon dioxide.
No, silicon, no, not silicon dioxide. Can you explain how silicon dioxide is deposited or the growth is happening?
Uh, Basically, in general, we are using silicon dioxide when we taking SI wafer. Uh,
Okay. And how we deposited or grow the silicon dioxide? Any technical name?
uh,
The process name, actually, I'm asking about.
yes, ma'am. During the process of
Like oxidation process.
yeah, oxidation process. Yes, ma'am.
Yes.
Oxidation process. We are depositing the SiO2 layer, and SiO2 layer is actually uh, non-conductive layer
Okay.
of silicon.
So, how many types of oxidation process is present? Have you heard about dry oxidation or wet oxidation?
Yeah, ma'am. Dry oxidation, wet oxidation.
Okay. Actually, here for MQ3 gas sensor, na, stannic oxide is used. Okay.
There are different types of MQ sensors. Maybe I have I have not read it, so it's,
Okay. But for MQ3, stannic oxide is used. Now coming to the question number 10. The MQ3 gas sensor shows a rise in temperature during the operation when measured with an infrared thermometer can be used to. The first option is a heater within the sensor, and the second option is the redox reaction happening is exothermic, and the third option is the both A and B, and the last option is none of the above. So now please go through the question carefully and try to give the answer. The MQ3 gas sensor shows a rise in temperature during operation when measured with an infrared thermometer can be due to a heater within the sensor, and the second option is the redox reaction happening is exothermic, and the third option is both A and B, and the last option is none of the above. Shamal,
yes,
please
ma'am.
go through
A
the
heater,
question carefully and try to give the answer.
ma'am. A heater within the sensor is correct.
Okay. And what about the second option?
The redox reaction happening in exothermic. I have doubt, but
ये होता है
But
कि
first one is correct.
Okay.
तो
Yeah,
साला
first
दिन भर
option
में
is
पाँच आदमी
correct.
को
And
मतलब
what about the second? I'm asking about what about the second option?
एगो और बात बोले के रहो हम बात
Exothermic
देख मेन बात है जे
gas.
साहू जी हमरा फोन करके बोलती है बेचारा ध्यान से सुनिए जे 23-24 जो इलेक्शन है ना 24 के
Because, ma'am, in exothermic redox reaction, oxidation reduction, both processes are happening simultaneously.
हेलो
So,
Okay.
ना सुन लिए इतना बोलियो
both processes are
सुन
happening.
ना एगो बात हम बोले के हो कि
So, it
24 के
is
जो
also
इलेक्शन है
correct.
ना
The redox reaction happening in exothermic. Exothermic
Okay.
means
So the right option
heat
is
is coming. Both A and B. Right option
the
is C.
option C, right? Both
Yeah,
A and
both
B.
A. Yeah.
Pritam hogi. Am I audible,
Yes,
Pritam?
yes.
Okay, so here the question is the NQC gas sensor show a rise in temperature during the operation when measured with an infrared thermometer. Can be due to a heater within the sensor. Or second option is the redox reaction happening is exothermic, and the third option is both A and B, and the last option is none of the above. So what is the right option?
No idea, ma'am.
At least try, na. Go through the question carefully, then at least try. Then I will explain what is the right option.
I have some idea in second option, but first one is I am sure.
Okay. Your answer is option C, na? Both A and B.
Yeah, yeah. My option
Okay.
answer is option C.
Okay, okay. And what about Preetham?
It should be, I think, C option.
Yes, the right option is C, both A and B. Because a heater within the sensor also the reason and the redox reaction also happening. So option C is the right option.
Can you explain the B, ma'am, if you it's possible?
The redox reaction happening in exothermic. So what is happening in exothermic reaction? Some heat is generated now. So here if you want that our sensor is accurately run now, so in that time we added a micro heater within the sensor, or sometime a redox reaction happening there, so it increases the temperature, or it of the exothermic, so some heat is generated. This is telling about it.
Okay.
This question number 11. A silicon ingot is subject to crystal trimming and diameter grind. After flat grinding, the silicon wafer has one primary flat with secondary flat at 90 degree. The doping and orientation of silicon wafer is. So what is the right answer? Basically here telling about the angle between the primary cut and the secondary cut. If the angle between the primary cut and the secondary cut is 90 degree, then what type of silicon wafer it is? P type 100, N type 100, or P type 111, or N type 111.
Silicon wafer has one primary flat with secondary flat at 90 degree.
See, if round shaped silicon wafer is present and there is a primary cut, and another in other portion there is a secondary cut, so I'm telling about the angle between the primary cut and the secondary cut. If it is 90 degree, it means it's perpendicular. The primary cut and the secondary cut is 90 degree. Angle between it is 90 degree. Then what type of silicon wafer it is?
हेल्प कर दे मांगे भी ना जाए तो की है वो बात ना बोले एक जगह बनाओ तो पीछे हम कर कराऊंगा
And it's P type.
Okay, P type 100 or 111.
It's 90 degrees, so it's 100.
Yes, the right option is P type 100. So option A is the correct answer.
If it is 180 degree, then what will be our answer?
Yeah, we are moving towards the next question. It is same, na? You were
Yeah,
asking. So yes,
yeah, yeah.
at first you try, then I will explain. A silicon ingot is subject to crystal trimming and diameter grind. After flood grinding, the silicon wafer has one primary flood with secondary flood at 180-degree. The doping and orientation of the silicon wafer is: first option is the p-type 100, the second option is the n-type 100, third option is the p-type 111, and the last option is n-type 111. So at first you try, then I will say the right option.
It's 180-degree now.
180-degree.
A-
It means there is a primary cut and secondary cut. It is
And
180-degree.
type 100.
Okay, n-type 100. So now what about Shamal?
जैसे समझने का कोशिश ही ना करें, हमसे सारा चीज सीखने को
Silicon
जाना
wafer
है,
has one primary
सोच के
flap,
हम कोई डिसीजन लेते हैं।
secondary flap at
हम
180
कुछ दिन
degree.
करते कराते कराते कराते
Finally, P-type.
See,
अरे बच्चे को
in
डॉक्टर
previous
बोल
question, what is asking? It is asking that in between the primary and secondary card, there is a 90-degree
Yeah.
angle. So it is called P type 100. And when it is 180-degree, like
Oh,
if
it's
it is
it's
round
yeah,
shape, then here the
yeah.
secondary card and here the primary card. It is 180-degree. And in previous case, here it is present. It's mean the 90-degree here. Okay. So what is for 180-degree? If the angle between the primary cut and secondary cut, then it is p type or n type. At first say p type or n type, then it is 100 or 111.
कल में बोला तो हम एक्चुअली
I have a doubt. If it's rotate by 180 degree or 90 degree, then its type also change.
No, here it is not telling about the rotation. Na? Here
Hmm.
only simple the round shape silicon wafer is present. There is a cut, small cut and bigger cut. Bigger cut is called primary cut and the small cut is secondary cut. So here in the round shape, here the primary cut is present and in that side there is a secondary cut is present. And the angle between the primary cut and secondary cut is one. In previous case it is 90-degree and here in this case it is 180. It means here the secondary cut, here the primary cut, and this is round shape. In previous case it is p type 100. So if it is 180-degree, then what is which type of silicon wafer it is?
I'm not sure, but it's N type maybe.
Yes, it is just a coding to identify the wafer, how we can identify the wafer. So if it is 180-degree na, then it is
Yes.
in type 100.
Okay.
Okay, so option B is the right option, in type 100.
हेलो
If it's 270 degree, then what will? Again, P
Actually,
type.
here what is happening? 270 means what? There, no. Yes, if 40-degree, na. I think next question is about. We are going through the question. Okay, this question is coming next. After two, three question, then we will discuss about this question. Okay.
Yep.
270 its mean is 40-degree. If we are taking this side, na, so it is 40-degree, 45-degree,
Okay.
right? And if
Yeah.
it is 360, it means there is no secondary card. So what is happening
Okay.
for that case? We will discuss later. So here we
Okay.
are telling our next question is the agent of silicon dioxide. So there are different type of etching is present. So can you explain about the have you heard about the dry etching or the wet etching process?
Yes, ma'am.
So what is happening in dry etching process? The basic principle I'm asking about.
In dry etching, we are using different type of gas ion to etch and the, that portion.
Okay, gas or plasma. And what is
Plasma.
happening in wet oxidation? Wet etching process.
In wet etching, we are using different type of chemicals for each end of that portion where we want to etch.
Some liquid type chemicals, no?
Yeah, yes, ma'am.
So when we go for etching the silicon wafer, then which type of process we will follow? So silicon, which type of chemical etching process we will follow?
BHF.
Silicon.
Sorry, what?
BHF में.
BHF. No, I'm not asking about the silicon dioxide etching. No, I'm asking about silicon wafer etching process.
KOH, potassium hydroxide.
Okay, KOH. And any other name?
Uh,
TIMA also there.
Yes, yes, TIMA. And what is the full form of TIMA? Trimethyl ammonium hydroxide. And so it is anisotropic or isotropic. Do you know about what is isotropic or what is anisotropic basic principle?
Isotropic, I think, etching from all side, and the anisotropic is the direction, just in one direction.
So TIMA is anisotropic or isotropic?
TIMA, I think, is a wet process, so it's isotropic.
TIMA is isotropic.
If it is chemical, I don't know it's a chemical or.
Yes, TIMA is chemical. Their chemical solution is present in TIMA, trimethyl ammonium hydroxide.
So all the
So
wet
here we
agents
dip the
are the
silicon.
isotropic.
If we dip the silicon wafer, na, and if there is a mask is present, like if we want to prepare a diaphragm, like for pressure sensor, we want to prepare or want to fabricate a diaphragm. Na, in that case, we dip the wafer into this stima solution to etch the silicon in the back from the back side, and there is the mask is present. Na, silicon dioxide mask is present. So here the silicon dioxide mask is present, and then that type of shape we want, and we dip the wafer into the TIMA solution. Then what is happening? How the in pressure sensor? Do you remember the shape of the diaphragm? How it looks like?
It's like a
Like this type of shape is present.
plane,
Na? Here the
plane of the
diaphragm and
tiger.
this type of shape. Something angle is present here and this type of shape, right?
TU type.
Yes, that. And what about the angle between this, like this, if there is a diaphragm and this type of shape is present, so what is the angle between this? Do you know about it?
Yes, we around 130, 120 degrees.
Mm, actually, a 100 and 11 plane, between the 100 and 11 plane, na, the etching, where the etching is happening in that portion, the angle between is 54.7 degree. Have you heard about it? The angle between 100 and 111 where the etching is happening now, the angle between it is 54.7 degree. So it is in particular direction it is etching now. Here is the mask is present, then in particular direction it is etching, like this type of shape is formed. So which type of process it is anisotropic or isotropic?
ना हमरा आज के पहले ना कि बोले थे कि जो किसी का बात नहीं
If
थी
it is in the particular direction it is etching for silicon agent, the if we dip the wafer into the
It's
tima,
an isotropic.
yes, it is anisotropic. And what about,
हम
and
पूरा
here we are
बुड़बक
asking
को
about the silicon dioxide agent. So what is the right answer?
BHF.
Yes, BHF. And it is anisotropic or isotropic agent?
This is isotropic.
Yes. Why this is isotropic?
Because it is etching from all sides.
Yes, it etching in all the direction at the
Wet
same rate.
chemical
Okay,
all the.
but in anisotropic etching process, in particular direction, it is etched out. That's why the right option is BHF, buffer hydrofluoric oxide. And what about Shamal? Can you explain what about the DRIE process? What is happening in DRI? It is chemical or the weight aging or the dry aging process.
DRI.
Yes. What is the full form of DRI?
Sorry, ma'am.
Pritam, what is the full form of DRI?
Deep reactive ion etching, I think.
So it is dry aging or the wet aging process.
It's a dry process. I think we use plasma in this.
Yes, yes. So it is a dry aging process. So Shamal, what is the right answer here? The SiO2 agent is
BHF.
okay, and it is isotropic or anisotropic?
Isotropic.
Yes. And Tima?
Tima is an isotropic.
Yes, Tima is anisotropic. Why Tima is anisotropic?
Uh, you are saying because it's itching from all sides.
No, no. If it is aging from all side, na, then it is called isotropic.
Okay,
But
okay.
if it is aging in a particular direction, then it is called anisotropic. Okay. And in the aging process, the angle between 100 and 11 plane na 54.7 degree. That's why this type of shape is present when we go for the pressure sensor. Fabricate the pressure sensor, we want to make a diaphragm type structure. So in that case, the angle between 100 and 11 plane is 54.7 degree. So next we are moving towards our question number 14. For dry oxidation, which equation is right? Silicon plus oxygen. So it is preparing the silicon dioxide, and then silicon 2H2O, and then it is from the silicon dioxide and 2H2. Or third option is both, or the last option is none of the above. It is very simple question. So the
Both.
example of the okay dry oxidation process. So Shamal, but go through the question carefully and try to give the answer.
ना तो हम आके यदि पूछ लेंगे कि उसका के की बोला के का है रोक ले तो हम कैसे नहीं
Ma'am, second one I have a doubt,
Okay.
but first one is correct.
At first, tell me what is happening in dry oxidation and what is happening in wet oxidation. Then we will go through this equation.
अभी मिला था तो फोन ना मिला हम समझ गए कि तू झूठ बोल रहा है
Uh,
अरे तो हम समझ रहा लिया तो हम तो बोले किसी को फोन मिला था कि किसी के बोलते कि काम ना तो किसी रोक लेते तो फोन ना मिला
in dry oxidation, ma'am, we are using that
हम समझ गए कि
reagent or chemical uh, which is on their dry state.
And what about wet oxidation process?
In wet oxidation, we are using that chemicals. They are on their liquid process, liquid
Actually, it
condition.
is not in liquid process. In wet oxidation, now we are adding some water vapor. Okay, this is the main difference because in dry oxidation process, only oxygen gas is used, and then oxygen react at high temperature, like 1200 to 1500 degrees centigrade. It's react oxygen molecule reacts with the silicon wafer, and it prepare the silicon dioxide. And in that time, the if oxygen react with the silicon, na, some silicon is consumed, and it's prepared the silicon dioxide and it growth on the silicon wafer. And what is happening in wet oxidation process, we used some water vacuum, or sorry, vaporized water molecule. Okay, so vaporized water molecule and oxygen then reacts with the uh, silicon here on, yes, water molecules will react with the silicon, and then it prepare the silicon dioxide and some hydrogen gas. Okay, so what is the right answer here?
A.
Option A. So, our next question is wet oxidation is about dash time faster than dry oxidation. So, at first, tell me which process is faster, wet oxidation or dry oxidation? Wet
Wait.
oxidation is faster. Now, the question is wet oxidation is how much faster than the dry oxidation process?
10 times.
Yes, 10 times. Pritam?
10 times.
Okay. The right option is the 10 times faster than dry oxidation process. Next, we are moving toward the question number 16. For dry oxidation, the thickness of oxide is first option is 0.05 to zero point 0.5 micrometer. Second option is 0.5 to 5 micrometer. Third option is 5 to 50 micrometer. And the last option is none of the above. So, what is the right answer? Let's see. In dry oxidation, what is happening? The less amount, it is quality is better, na? But the slow, the process is very slow. So for dry oxidation, the thickness of the oxide layer also thin. So it is the now tell me the right option. The thickness of the oxide is
0.05 to 0.5 micrometer.
which option? Option B or A?
A.
Okay. Preetham?
A.
Okay. So the right option is option A 0.05 to zero point 0.5 micrometer because in dry oxidation process the thickness of the oxide is very thin
Yeah.
because
As
the
compared to weight
oxidation
oxidation.
rate is very slow.
But, ma'am, in weight oxidation, what is the thickness of the oxide?
Yes, the next question is for weight oxidation, the thickness of oxide is. So, what is the right answer? Less than 2.5 micrometer or greater than 2.5 micrometer or greater than 5 micrometer? Because here the oxidation process is greater than the uh, dry oxidation process. So, obviously, the thickness is greater than the dry
Greater than
oxidation
2.
process thickness. So, what is the right option?
Greater than 2.5.
Greater
C.
than 2.5 or less than 2.5?
Greater
In
than
dry,
Oh,
is
no,
greater.
when where for wet oxidation, na thickness of oxide. Like here, the maximum thickness for dry oxidation, the maximum thickness is 0.5. So according to this, the for wet oxidation, the thickness of oxide for wet oxidation.
So it's less than 2.5.
Yes, less than 2.5. Next question is in wet oxidation quality suffers. I have told you earlier what is happening in where dry oxidation the quality is better, but the oxidation process is very slow. That's why thin film of oxidation, like the thickness of the oxide, na, is very less. But in wet oxidation, the thickness, the oxidation process is very fast, and the thickness also greater than the dry oxidation, but the quality is not good. Well, if you want to use it, the silicon oxide, use it as a insulating layer, na, in that case we can easily use. But why the quality degrades for wet oxidation? Now the first option is the diffusion of the hydrogen gas out of the film. What is happening, what is happening in the wet oxidation? The water more vapor is used, na? So the diffusion of the hydrogen gas out of the film which create path the electron can flow, and the second option is the diffusion of the oxygen gas out of the film which create path that electron can flow, and the third option is none of the above, and the last option is all of the above. So what is the right answer?
Ma'am, it should be none of the above, nice, ma'am.
No, hydrogen gas is coming out now. Where,
नहीं,
but
hydrogen came out, I understood, but the path for oxygen atom and not for electrons.
yes,
Oxygen molecule should be path. नहीं, there is a no oxygen molecule. They are not talking about the oxygen molecule path के लिए. This is only talking about the electron can flow.
yes. So the right option is option A now. Their diffusion of the hydrogen gas na coming out of the film. So what happened if the hydrogen gas coming out? So that it's
It
create the
create
path
the
na.
porosity which give the part to the oxygen molecules which we providing from outside, not for the electron can flow through that. Why the electron help in oxidation? My doubt is that there should be the path for the oxygen molecule, not for electrons.
No, it is also create the path for the electron flow. You can recheck it. Okay.
Okay.
Okay, so the right option is option A. That in the for the diffusion of the hydrogen gas coming out the film, it's create the part for the electron can flow. You can recheck it. So next the question number 19 is in oxidation process how much silicon is consumed. It means when the oxygen or or H2O molecules is react with the silicon na, and it's producing the silicon dioxide. In that time some amount of the silicon also consumed. So what is the percentage?
46, I think.
Yes, 46%. Next question is the characterizations technique for measuring the thickness of silicon dioxide is surface profilometry, color of the oxide layer, or ellipsometer, or all of the above.
I think all of them.
Okay, so right option is all of the above. But have you think that
I
color
have
of
used
the
ellipsometer, but I did not use this surface profilometer or color of the odors.
yes, surface profilometry is also used to measure the thickness of the silicon dioxide. Also from the color code, now we can, but we have to expert on this. If from this
Okay,
color code,
just for experiencing the color of the wafer from the top.
yes, yes.
Okay,
So in that case, if we are expert, so from seeing the color of the silicon dioxide, we can see the thickness. It's mean the average thickness we can tell how much thickness of the oxide layer. And in
okay,
ellipsometer also we can measure the thickness of the silicon dioxide. So the right option is all of the above.
okay.
So the next question is in surface profilometry we have to pattern step by lithography measure the thickness of the oxide. So it is true or false?
It's
When
a
you go
false.
for
I think is
what is the right answer?
false. I think
Why false? Can you explain how to
in
measure?
surface profilometer we have to pattern step by lithography, but
Yes.
we are just observing na the thickness of the
Yes,
oxide
if we
through
go for
surface.
observing the thickness, na, how we
Mm-hmm.
will observe? At first, tell me how we will observe in surface profilometer, and in that case, what type of process is need? At first, tell me what is lithography process.
Lithography is just patterning the some structure on the wafer through the photoresistor and
Can you explain the total process,
whole
like
process.
what is happening in lithography? First, what is happening?
Okay, first we have to spin coat the photoresist.
Where we spin coat the photoresist, we are taking an wafer. Now, after taking the wafer, we have to clean it. So, what is the cleaning process?
Wheel cleaning process that is acetone and then IPA and one I think needed if needed the piranha solution also we have done.
Yes.
And then
Then,
after dry the wafer, then spin coat the PR,
which gas is used for dry the wafer?
nitrogen,
Okay. Then,
then spin coat. Before we can also You put the 1 minute for the hot plate to the remove the moisture or anything from the wafer.
Okay, and what about the temperature and time? It is called
100
soft bake
degree
process, na?
soft bake is I think after the spin coat,
Yes,
but I'm
after the
talking about
spin
just
coat, the
before.
soft
I
bake
am
is
talking about just before the spin coat. We can put the wafer for 1 minute to just remove the moisture from the wafer.
okay. And then,
Then spin coat, then soft bake.
and what about the time and temperature?
I think 110 degree for 1 minute soft bake.
No, actually, for the standard temperature is for the soft bake is now 90-degree. If
Okay, so
we use
110 I think for hard bake. I think
yes, and if we use the AC weight, then what is the soft bake temperature?
SU8.
Yes, it
I
is
don't
also
remember.
explained in previous lecture. Like week 4 lecture, it is already explained for
I
AC
think
weight.
that is a less temperature. I think 65 degree. I think.
Yes, yes,
Yes.
65-degree. And what about the time?
Time I don't remember. I think
It
1 minute.
actually for AC weight, na, the time is depends on the thickness of the AC weight. And
Okay.
if we go for the negative or positive photoresist, in that case, the time is 1 minute. Then after soft bake, what process?
Soft base. Then after we have to expose or if needed the alignment also.
So before expose, we have to load the mask, na?
Yes. That is alignment part. I think.
Yes. Then
Then expose according to the dose of required for that photoresist.
okay. Next.
Size like is 1 minute or something or 20 second maybe some like in S1813 may I think we use 20 second. Then after we have to develop in the developer solution.
Hmm.
Then hard bake I think
Hmm. Then what is the temperature in hard bake, and what about the time?
1 minute for 120 degree centigrade hot plate
Yes. And if we go for the AC weight, then when the hard bake process is going,
and don't remember about SU8.
okay, for hard AC weight, na, after the soft bake, we go for the hard bake process. And after the development, na, we have to heat the wafer or the device greater than 125 degrees centigrade. This is the basic difference.
Okay.
So, what about the what we do for after the um, hard bake?
हार्ड बेक के बाद जस्ट हो गया ना आई थिंक लिथो
After hard bake process, then we have to remove the photoresist, na?
so photoresist we have to remove the photoresist using
Or
acetone.
after hard bake process, we have to go for the etching process, I think.
Yes,
If we have to go for the etching
wherever we
process, and after
remove the
etching, we go for photoresist
whatever
removal.
process we photoresist remove, then whatever process we have to done after the litho.
Yes. So here what is happening now, for a surface profilometer, we have to measure like this type of pattern is this type of wafer is present. So in some portion the material is deposited, and in some portion now the material is not deposited. So we have to form like that. Some in some portion material is present, and in some portion material is not present. So how
Yes.
can we prepare this type of shape? Like we have to etch something, some portion, then we go through the surface profilometer, then it can measure the height difference where the material is present and where the material is
Here is
not
the not
present, right?
okay.
So in that case we have to pattern now. If there
Okay.
is the step is not present, then at first we have to pattern by the lithography process, we have to prepare the step, then we go for the surface profilometer where the step material is deposited and where is it etched out. We have to calculate the difference, the height difference between it. That's why at first we go through the this lithography process, then we pattern the step, then we go for the surface profilometry. Okay.
It's true.
So it is a very simple question, the example of the PVD technique.
It's all are the PVD techniques.
Yes. Can you explain the, whole process of the PVD, what is happening, and how the sample is loaded, and how the source material is taken, and the melting point. What about the melting point of the source? So where the source is taken?
Okay. So in every PVD process, we have to need first the vacuum system, like any bell jar or anything vacuum chamber. So for that, we have to first we have to vent the system if you're already in um, the in high vacuum earlier we have used. So first we have to vent, then for vent we have to purge the nitrogen or any uh, inert gas, and then we have to load the sample and the target material that we want to deposit on the our substrate. Then after closing the chamber, we have to again start the vacuum system. So first we use roughing pump. I think for the that we use rotatory or rotary pump, what we call it, for 10 to power minus 10 or something a millibar. And then after reaching 10 to power minus 10, we have to start the high vacuum pump like a diffusion or any turbo molecular pump, then reach the required that vacuum 10 to power minus 6 or 10 to power minus 5 around. Then we have to use whatever is our system, like in a beam we start the supply of the electron beam, or in sputtering we have to put the gas or start the supply of sputtering system like RF or DC. Same in thermal also, we have to start the heating material, that heating current for the target material that we have put in the system.
Okay. So what about the melting point? The like we are taking some material which we want to deposit, okay, and there is a
Hmm.
source where we taken the material. So what about the melting point?
The material melting point that we want to deposit, that should be low,
Yes. Why?
so we can easily evaporate that material.
Easily evaporate if it is not happening. Like if the source where we taken na, if the melting point is lower than the material we want to deposit, then what happen?
Which melting point is low? Is substrate.
Like where we taken the material, some material we want to deposit, this melting
Yes.
point is higher, and the where
Hmm.
we taken na, its melting point is lower.
I'm not getting your point. What you are?
Like the
Suppose
boat,
there is a material A that we want to deposit, that
yes,
has the
it's
highest
higher.
melting.
Like the material we want to deposit, its melting point is higher, the boat where it is taking, this melting
Okay.
point is lower, then what happen?
No, the boat material is we using moly or anything, na, that is very high melting
Yes,
point.
it if it is not, then what happen? I'm telling about it, I'm asking about it.
In this that case, that material also can deposit on the wafer if it
Yes,
melted.
that's why we
Use
take.
this high melting material for the boat, or keeping the what we call that. I think one is boat or another thing is, I don't remember the name.
Okay. And what about the CVD technique and the different type of CVD process?
CBD I have not used, but in that we have used some chemical that react before deposition, during the deposition.
Okay,
In
what
PVD, just
happened during
we
the
the
deposition process?
In
Like how
chemical,
the
there is a
input is taking, how the gas is following, why it is used, and how the deposition is happening in CVD, and which
like
type of CVD is present.
one is PV, the plasma CVD,
Okay.
and one is the normal CVD, I think.
The
But
CVD
I
called
think the
APC,
oxidation process is a kind
atmospheric
of a
pressure.
CVD process.
Okay.
APC.
So what happened in CVD process?
There is a chemical reaction with the material, then it is depositing on the substrate.
Chemical reaction, how the chemical reaction is happening there?
We putting suppose some like oxidation. Sorry, that suppose we want to deposit a silicon oxide, so we have to send to like oxygen or so that is react with the silicon. I think this kind of reactions. I think CVD
Like
or
silicon
maybe two
dioxide,
gases
like
or
we are
maybe
taking a simple example of MOS2. For MOS2 we are taking the chemical in solid form like sulfur or molybdenum oxide. The both are in solid form. So at first what we are doing, at first they give some temperature which is the where the melt it's greater than or it's equal to the melting point of that material. Okay, and in
okay,
that time there is a gas flow which is
the
which
oxygen.
acts, sorry.
So whatever sulfide or oxide we want to deposit with molybdenum.
Yes, for ammo's to deposition molybdenum disulfide.
So we
So
have to put the sulfur also.
yes, we have to take the sulfur and molybdenum oxide, then we have to maintain the temperature according to its melting point. Then it start when we start the system, then it's evaporate, the chemical evaporate and start reacting, and the carrier gas argon is following flowing.
Ara.
So using this carrier gas now, this MOs2 after reacting this MO3 and the sulfur it's become MOs2, and using this carrier gas it deposited on the surface. Okay, have you got my point?
Yes, ma'am.
Okay. Next, we are moving towards question number 23. During the thermal evaporation technique, the angle between substrate holder and the source material is, the first option is 120 degrees centigrade, the second option is 90 degrees centigrade, the third option is 45 degrees centigrade, and the last option is 30 degree. Sorry, not centigrade, it's 30 degree, the angle. So, what is the right answer?
120.
At first go through the question carefully. During the thermal evaporation technique, the angle between what? The substrate holder and the source material. What is the angle between it?
We put the substrate down and target is above side, so it's 90 degree.
Yes, it is 90 degree. So the next question is, in MQ3 gas sensor sense ammonia, alcohol, hydrogen or smoke?
This lecture not attended.
Okay, so MQ3 gas sensor na, it is used for alcohol sensing.
Okay.
And the next question is, the common types of MEMS materials are ferroelectric, ferromagnetic, ferroelastic, or all of the above?
Maybe all.
Yes, all of the above. Can you explain how we can fabricate a pressure sensor, like the whole photolithography process from back side and from front side also? How you can fabricate the whole fabrication process for a pressure sensor? Can you explain?
Pressure sensor.
Yes. The process step.
Mm. That diaphragm thing that you are asking.
In front side we have to pattern na the some
The some
id
that
pattern.
ID patterns, and
Yes,
the
how we will,
downside
how
the,
we go through it. I'm asking about the photolithography process. How you can fabricate a ID pattern on the front side, and from the back side, how we can pattern the like this type of shape, like the diaphragm. How we can age. I'm asking about the process flow.
we already discussed. The litho is the same thing. That is, suppose
Yes,
we want to that ID pattern, that we can take on mask and we can pattern using the litho, and then deposit the metal on that PVD technique or any like sputtering or any technique. And then below side, we already discussed in previous questions, you use TIMA for the creating that big
but
bulk
in
machining for.
that case, only now my question is in the below portion, only the silicon wafer is present or oxide also present in the back side. I'm not telling about the front side.
Yeah, we have to remove that silicon oxide and some portion of the silicon also from the back side after patterning it using any litho.
Yes, by using the photolithography process in some portion from the back side, so we have to remove the silicon dioxide, like, and the remaining portion used as a mask. So
Yes,
where the silicon dioxide is present now, in that portion the silicon is silicon also remaining, and the other portion where there is a whole type of portion now where we remove the silicon dioxide, in that case this type of shape is present,
yes.
right? So
Hmm.
then we dip the wafer, but after dipping the wafer into the solution, we have to coat the no, wafer, na, the remaining portion. There we have to coat with photoresist, and the back side, front side also we have to coat with the photoresist, because in that time, na, there is silicon. For removing the silicon dioxide, at first we dip into the BHF solution. So for front side also the silicon polysilicon dioxide, polysilicon dioxide is sorry, polysilicon is present now for id pattern. Id pattern, there is some material is present,
Yes, we have to
polysilicon.
save that also by
Yes,
using
it
any.
also can remove, or in below the polysilicon there is silicon dioxide also present, so it can remove. That's why what happened, we have to protect the front side also. So we coated with the photoresist in the front side. Then we dip the wafer into the TIMA solution. And TIMA is an anisotropic or isotropic?
Anisotrope.
Anisotropic. So in a particular angle it etch out the silicon, and then after etching we measure the remaining thickness. Actually, how much thickness is present, the diaphragm thickness, how we measure how much amount of silicon is etched out. So we at first we measure it, there is a step type of portion now. So in some, for using the surface profilometer also we can measure the thickness. And basically it's for surface here in the lecture video, the surface profilometer, actually the thickness of silicon dioxide is measured. So in that process we can fabricate a pressure sensor. This is the next question. So the next question is, if the input energy is magnetic, the output energy is thermal, then the material property is magneto-resistance, magnetostrictions, electrostrictive, or magnetocaloric. So what is the right answer?
The name is suggesting, I think, magnetocaloric.
Yes, the right option is magnetocaloric. Caloric. And the next question is, which software is used to, in the lecture video for simulation of the MEMS device? The first option is Silvaco TCAD, second option is the console, third option is the Cadence, and fourth option is none of the above or all of the above.
Console, I think.
Yes. And why, where we use Silvaco TCAD? Do you know about it?
Shilwako, the people using for the that nano and microelectronic devices like transistor or any.
Yes. And what about the cadence?
Cadence is, I think, for analog, that what we call it, some circuit purpose,
Yes, some
circuit
circuit
design.
purpose. And why we need this simulation process? Do you know about it?
Yeah, to save the money and the time and the complexity of the system before the making the prototype.
And also we can compare now how
We
much
compare the many structures and data in
actual
different
fabricated
conditions.
device.
Yes.
Yes. And the next question is in piezoelectric actuator. So tell me what is actuator? What is happening in the actuator? Which form of
Actually,
energy convert into what form?
in motion, any
Yes, in
energy that
motion.
with motion.
Okay, so in piezoelectric actuators, input energy is voltage, or then the output energy is displacement, or input energy is current, or output energy is displacement, or input is force, or output is voltage, or none of the above. So, what is the right answer for piezoelectric actuator? At first, tell me what is happening in piezoelectric sensor,
In piezoelectric sensor, the force is converted into voltage.
and for piezoelectric actuator.
The voltage is converted, I think, into displacement.
Okay. Voltage convert into the displacement. Yes, the right option is option A. And the next question is electrochemical glucose sensor use the amperometric method to measure the concentration of the glucose in sample. So it is true or false?
I think true.
Yes, the option is true. So in glucose sensor, basically it is, do you remember it is in vitro or in vivo or ex vivo process?
That
Sorry,
what we
it
call
is minimally
minim,
something
minimally
something is
invasive.
present, na?
Yes, it's
Yes,
minimally invasive. We're just
invasive,
taking one
minimally
drop.
invasive. Why it is minimally invasive process?
We're just taking one drop of blood from the body.
And if we are doing the experiment or something detection process in into our body,
That is invasive.
invasive, and if we
The
are taking
out of the
out,
body is non-invasive.
okay. And this is our last question. If we want to grow any dielectric layer, which oxidation process we will follow? Wet oxidation, dry oxidation, or none of the above, or all of the above?
For
So
dielectric
at first
purpose,
tell
I
me
think
for
dry.
dielectric process, which type of oxide layer we want? Pure
It's
or
a
it
dry.
is insulating layer?
Insulating layer. It's a dry.
Insulating layer means the quality. I'm taking talking about the quality.
This should be not contaminant or any trap-free thing, so, or
So
a
we,
non-porous. So dry thing, dry oxidation we use in the gate oxide.
yes, for dry oxidation process we'll get the high quality, right?
Yes.
And now, if you have any doubt, then you can discuss with me. This is our last question. So, if you want to discuss any topic like any of the process,
No, regarding not this about questions, but I giving just suggestion. Whatever you uploading in that Google, that Excel sheet, now we can get that without instead of PPT. Can we get the all the question in any a Word file? Because taking all the question in one file is a labor work. You already have somewhere these questions, so can we get that?
like in what file you want this question?
You just uploading this PPT in that Excel sheet, no? That course Excel sheet, where we downloading this, your PPT is there. So the one PPT has a one question. I am it need that one Word file or any PDF file where all the question are there for one
Okay, in
lecture.
one page you want all of the question.
Well, one or three page or two page, because now we have to take 30 slides from the your PPT and then copy and paste from the.
Okay, then I will upload like in that form. Okay.
Okay, thank you.
Okay. From next session, you will get it.
Okay,
Okay.
thank you.
Thank you.
Happy holiday.
Okay. Mm. Santosh? Hello? Santosh? Am I audible? Hello, Jayashoda ma'am. Hello? Hello? Am I audible? Jayashoda ma'am, am I audible? Do you want to discuss any of the topic of the fabrication, MEMS fabrication process? Then you can tell or we can discuss. Like the oxidation process, photolithography process, or something else like PVD or CVD deposition technique. Oh, okay, then you can write now which technique you want to discuss. If the mic is one, then it is a little bit actually easy for me. I have discussed the 30 question in this session, and this session is already over. So if we want to discuss any question or anything, then you can discuss with me. And this is the week. Okay, okay. You just actually this session is over, so you can see the question and you can try. There is 15 minutes remaining, so we can try the question. Na? I can again start the session. So can I? You can write. If your mic giving the issue, then you can write the answer here. So now this is our question number one. which I have discussed with the today's session with the students. Can I start the session? Can I discuss the question? Or you want to discuss any particular topic? No, ma'am, sorry. So you don't want to discuss any particular topic or this question? Sorry, I'm not getting you, ma'am. Please respond. Okay, actually, this is a problem solving session. In this session, I have taken some of the question and then I discuss the question with students and I clear their doubt. At first, they tried, and if they are wrong, then I have explained the whole answer, how why this option is right and what is happening in that case, and if they have any doubt, then I have explained it. So if you want, then actually I have already explained the 30 questions. So if you want discuss with any of the topic like photolithography, oxidation process, or any of the step of the any of the deposition process like PVD, CVD, then we can explain, or we can again start the session like from the question number 1. But you have to respond in this session also. So what we want from it. If you have any doubt, then you can discuss with me. Jashoda ma'am, please respond. So any particular topic you want to discuss? But I will start the session. At least 10 question I think we will cover na, in that time. Or we will stop the session. Please respond. For that I should be started that, then okay, right, then at first you go through the video lecture na, then you can discuss with me. In any of the lecture session you can ask the question. If you have any doubt in the lecture session, then I will explain it. Okay, then it will clear your all the doubt. So at first go through the lecture session, and then we can meet the next our next session Tuesday 7 to 9 p.m. And at first you go through the lecture video and you collect the question, whatever you have doubt, then we will explain it. Okay. Okay, then in the next session you can ask. And now if you have any of the question like regarding this fabrication, memes fabrication technique, now also you can ask. And if you want to see the question, what type of question I discuss in the session, then you also can see. No, ma'am. Okay, then fine. Then we will meet in the next session. Okay. In this session, if you have no doubt, then and if you don't want to go through the question, then we will meet in the next Tuesday, 7 to 9 p.m.